So for this lesson, we are going to be discussing the last of the conic sections, which is the parabola. So the parabola is a locus of points such that each point is equidistant to a fixed point called the focus and a line called the directrix. So we can draw a line to any point on the parabola from the focus, and the distance from that point down to the directrix should be the exact same. So in this case, our locus is going to be that D1 equals D2. So for our types of parabolas, we do have two types. We have the vertical and the horizontal. And so the vertical looks a lot like what we dealt with in Algebra 2 because that is actually a quadratic function. And you'll find that your standard form resembles a lot of that as well. So the focus, of course, we only have one, unlike our ellipse and our hyperbola. That is always going to be inside the parabola. It's actually going to be on the axis of symmetry. And we'll review what the axis of symmetry is in a second. And the directrix always lies outside the parabola. And so the directrix is this line that is below. Kind of looks like it is behind the parabola. The directrix and the axis of symmetry are perpendicular. And so the axis of symmetry, that should be familiar from Algebra 2. But it is that line that looks like it is cutting the parabola in half. And so your vertex is p units away, the absolute value of p units away from the focus and the directrix. So your vertex is kind of the midpoint between those two things. And then the latus rectum is the segment that passes through the focus with the endpoints on the parabolic curve, and it does have a length of 4p. So the latus rectum is that line that goes all the way through. And let's see, in this case, we just go straight across, and it does have a length of 4 times p. So our standard form for a parabola. So for our vertical parabola, that is going to be x minus h squared equals 4p times y minus k. And it opens up if p is greater than 0, and it's going to open down if p is less than 0. So if you have a horizontal parabola, then your variables are going to switch, and you will have y minus k squared, and that is going to equal 4p times x minus h. And then you will open right if p is greater than 0, and you will open left if p is less than 0. So to graph a parabola, the first thing that you're going to do is write the equation in standard form and then determine the type of parabola. Then you will graph the vertex, which is h and k. solve for P to determine the direction of the opening, and then use the absolute value of P to graph the focus and the directrix. Then you'll use the absolute value of 4P to graph the endpoints of the latus rectum, and then use that to sketch the parabola. So for our examples here for graphing, we are first going to determine our vertex. So we have 4, -3. So we're going to be at 1, 2, 3, 4, 1, 2, 3 down. So there is our vertex. And then we are going to also look and see which way we're going. So it looks like we are vertical since we have an x minus 4 squared. Whenever you have that x term squared, it is going to be vertical. And then we will look at P here in a second to see which way we go, if that is up or down. So our focus, let's see, actually we need to get P. So we are going to go ahead and look at this term in our standard form because that should be 4 times P. So we're going to take 4P, it should equal 2, and then we're going to solve for P. So P equals 1/2. And so since P is greater than 1, we are going to open up. And that means that our focus is going to be 1/2 unit up from our vertex. So that puts us at 4, -2.5. So right here. And then 4 times P was 2. So the endpoints of our latus rectum is going to be essentially 1 unit out from each of these. So 1 unit to the left and right of our focus. And that is going to give us 3, -2.5, and 5, -2.5. So our axis of symmetry is going to be the x of our focus, just like in algebra 2. So that's going to be x equals 4. And so we're going to go ahead and draw that line through. And then our directrix is going to be 1/2 unit down from the vertex. So we are going to have 4 and then -3.5. And so that line will just go across. So here is our latus rectum. This one's kind of small, but then we are just going to use this to sketch in our parabola. And then, of course, if you need more points, you can always fill those in. Because this one actually has a couple more at, let's see, at 2, -1. And so we're just going to make that symmetrical. And so that gives us a little bit more to go off of. But we're just going to keep opening out. And there we go. There's our first parabola. All right, so then for number 2, we do have a horizontal parabola because our y is squared. So our vertex is going to be 0, and then -2. And then to find our focus, we'll need to solve for p. So we are going to take 4p and make it equal 8. And then we'll divide by 4. And so p is going to equal 2. And so we will go from 0, -2. And we are going to, let's see, and we do open to the right. And so we're going to go 2 in front of that with our P to get our focus. And so our focus is going to be 2, -2. And then the endpoints of our lattice rectum, that is going to be 8 across, so 4 on each side. So 1, 2, 3, 4. 1, 2, 3, 4. And so the endpoints of your lattice rectum are 2, 2. And then 2, -6. So our axis of symmetry is going to be the y of our vertex this time because we are opening horizontally to the right. So that is going to be y equals -2. And then our directrix is going to be 2 units back from the vertex. And so that gives us our dotted line there at x equals -2. So we're just going to sketch in our parabola at that point. And there we go. All right, so let's look at number 3. So this one looks like it is horizontal because we do have a y squared. And so our vertex is 5, 1. And then, so that gives us 1, 2, 3, 4, 5, and then 1 right there. And then our P, we've got 4p equals -16, so p equals -4. And so that has us opening to the left. And so we will go 1, 2, 3, 4 to the left to get our focus. And that makes our focus at 1, 1. So we will also go 8 on each side of the focus to get the endpoints of the lattice rectum. So that's 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. And so that gets us 1, 9 and 1, -7. And so we can go ahead and draw in our parabola from there, because we do have the lattice rectum in. And so our axis of symmetry is going to use the y of that vertex. And so that is going to be y equals 1. And then the directrix is going to be 4 units away from the vertex. So 1, 2, 3, 4. And so that gives us x equals 9. So for number 4, we have a negative 1/4 x minus 2 squared. So this is going to be vertical because it does open, well, we do have x squared, but we need to look at our p to figure out which way we open. And so this equals y minus 4. So that negative 1/4 does need to be moved so that we are in standard form. So what we're going to do is we are going to multiply each side by the reciprocal. And so we have x minus 2 squared equals negative 4 times y minus 4. So then we can go ahead and look at our vertex, and that is 2, 4. So we are going to go ahead and graph that. So 1, 2, 1, 2, 3, 4. And then the focus is going to need us to find p. So our p is negative 4. So negative 4 equals 4p. So negative 1 equals p. So we are going to open down. So our focus is going to be 1 unit down from the vertex. So that is going to be 2, 3. And then our directrix is going to be 1 up. So there's our directrix. Now the endpoints of our latus rectum is going to be, let's see, we're going to be 4 across, so 2 and 2 on each side of that focus. And so that gives us 0, 3 and 4, 3. So our axis of symmetry is going to use the x of our vertex. So that is going to be x equals 2. And then our directrix is actually at y equals 5. So we're just going to sketch in our parabola. There we go. All right, so now let's look at rewriting those equations in standard form. So to rewrite the equation, you've got to figure out, first of all, which direction should we open more than likely. So we have a y squared here, so more than likely we are going to open horizontally, either left or right. We'll have to get the rest of the way into standard form in order to see for sure. But what I am going to do is I'm going to put that y squared on this side by itself, and then I'm going to move all the other terms. So we're going to subtract the 12x and the 24. And then I am going to get that common factor out of the coefficients of my x's. So that gives me a negative 12 and then x plus 2. And so since we do have a y squared and we have a negative 12, this means that we open left. So for number 6, we have that x squared. So we're going to leave anything with an x on the side, and then we are going to add 6y to each side. So I am going to take x squared minus 10x. I am going to have to complete the square in order to figure out what that coordinate is. So we're going to have 6y minus 31 over here. And then half of 10 is 5. 5 squared is 25. So I'm going to add 25 to each side of the equation. And so that leaves me with x minus 5 squared. And then I have 6y minus 6. So then we can take out that GCF. Then we have 6 and then y minus 1. And so that one is going to open up because our x is squared, and then our p should be greater than 0. So for number 7, we are looking at an x squared. So we're going to leave all the x's on this side and move all the other terms. So we have x squared plus 2x equals negative 20y minus 61. And then we're going to have x squared plus 2x. We're going to have to complete the square. And so we are going to have to add 1 to each side. Then we will factor. So we will have x plus 1 squared. That's going to equal negative 20y minus 60. So x plus 1 squared will equal negative 20, and that will become y plus 3. So in this case, this opens down because our x is squared, and then our 4p is negative. So then for number 8, we have a y squared. So I'm going to move this x term to the other side, and I am going to subtract 14y to get it on the same side as my y squared. So we're going to have y squared minus 14y equals 2x minus 45. We're going to have to complete the square. So we'll have y squared minus 14y plus something equals 2x minus 45 plus something. And then when we complete the square, half of negative 14 is negative 7, and negative 7 squared is 49. So that gives us y minus 7 squared when we factor, and we have 2x plus 4. So then when we do get the GCF out of the 2x plus 4, we have y minus 7 squared equals 2 times x plus 2. And so this actually opens to the right.